Hey gang, welcome to Chapter 10, Fire Prevention Systems. We're looking at gas agent systems this week. So gas systems are kind of interesting. They're kind of cool the way they work. So this should be a short little video, only 19 slides, but I want to just jump right in and introduce the subject. So first of all, why do we have gas systems? Gas systems are there because there are so many new materials, new processes, new technologies. That's a really big part of it. We have server rooms that run what you watch on TV, that the cloud that you put all of your documents on, all of this, these are very high tech, highly expensive technologies and pieces of equipment, and water and chemicals are bad for them. So gas agents are an alternative, and they are very effective, but they're very, very expensive. So they're only going to get used in places where the cost versus the gain, right? If you've ever seen some of these server rooms with just rows and rows of data banks that are, millions of dollars in these rooms, while putting in a couple $100,000 CO2 system or Halon agent system, well, the cost is worth the gain. Okay? So this particular video is just going to be about CO2 systems. The next video is going to be halon agents, inert agents, and aerosol products. Okay, so CO2 agents are one of the main ones, carbon dioxide, the other three, halogenated hydrocarbons and inert gases, and they're very, very effective. Water is cheaper, a sprinkler system way cheaper to put together, but gas systems way, way better in the sense of effectiveness, but way higher in the price. So we're going to go with one of these when we need them. So the, carbon dioxide is an odorless, colorless, non-combustible gas. Hey, can I take a sip? My allergies are getting to me a little bit, so I got a little tickle in my throat. So CO2 is all around us. It's in the air, about 380 parts per million. It's in our atmosphere, and so it's a common gas, but they make it, for industrial uses. I'm sure that some of you are paintballers and you've got a gun that's driven by a little CO2 capsule. And there are all sorts of uses for carbon dioxide. So it exists both like water, one of the few products that can be a gas, a solid, or a liquid. To get it into a liquid state, they compress it into a cylinder. If the cylinder doesn't have a lid on it, it just dissipates, and next thing you know, it's gone. So they compress it into cylinders and tanks and things of that nature. The liquid state is best for our application for firefighting, for suppression. They store it in these cylinders or tanks in a liquid state, but when it comes out, it turns into gas. It's very effective on A and B and C-type fires. Very great as long as it's not conductive, right? With C-type fires, well, carbon dioxide is not conductive. It can work on flammable liquids. A lot of the special effects people that I work with in the film industry, they like to use CO2 a lot. They have CO2 extinguishers. So the CO2, how it works is it displaces and reduces the level of oxygen all the way to below 15% of the air content that's necessary for combustion. Now, that's really good. Boom, all of a sudden there's just not enough oxygen in the room for fire to continue. So it takes away the oxygen leg. That's how it works. Problem is, well, what about us? If we as firefighters are in the room or somebody is in the room, how much oxygen do humans need? Do you remember? Yeah, above 19%. When you start getting below 19%, you start getting a little altered in your thinking. You start getting a headache. You even go down more. But by 15%, you're probably going to die. So you shouldn't be in a room where the CO2 has been activated. I've seen people, when they're doing tests, walking around in it, and they think they're safe. Well, they might be slightly safe because it's down lower. It's heavier than air, and it goes down. But it's not a good idea. Don't be in a room where a CO2 system is activated. Like I said, it's 50% heavier than air, and it separates the oxygen from the fuel, thus extinguishing the fire. And when it's discharged, it goes from that liquid state and expands to a vapor state, and it can fill the area or fill a room. So now why, when CO2 is released, does it have a cloud? Well, it's cold. And it comes out and it's cold, and moisture is attracted to it, so it mixes with moisture, and that's why you see a cloud. Now, sometimes the cloud aspect, the moisture aspect to it, goes away. But that doesn't mean the CO2 is gone. So you should always use some kind of an oxygen meter before returning into the room, or be wearing an air bottle, an SCBA of some kind, after an activation has happened. CO2 is used when other agents like water or wet chem or dry chem would be a problem or not effective. Sometimes you need something that's going to envelop a piece of equipment. Like CO2 is used a lot for printing rooms, so they want it to work all the way around the system. Dry chem, you think, well, why not dry chem? It kind of envelops the area. Well, the particles in the dry chem are really bad for electronics. So I always like to tell a little story about that some paramedics saw another paramedic car at the grocery store. So they thought they'd play a little practical joke on them, and they were going to get in the squad and drive it around to the back of the grocery store and park it and hide it, and see what the guys did. Well, they went to get in the car, and like good paramedics should do, they had taken the keys. Sometimes guys leave the keys in. They had taken the keys, and they had locked the car. So it was summer, though, and one of the other guys, bound and determined to play a practical joke, said, "Hey, I got an idea." And he ran and he got this dry chem extinguisher. And he put it was summer, so there was a crack in the window. And he put it in the window, and later on, he said, "I only just pushed it just a little bit." And he squirted the dry chem into the vehicle. Well, it turns into this big cloud of white, and then settles down in this squad. The guys come out, and it's a total mess. It's all over their turnouts. It's all over the seats. It's all over the equipment. And it's not good for you to breathe this stuff, right? So they're trying to get it out. They're waving their turnouts and stuff, trying to get this stuff out. Finally, they get in the vehicle, and they decide, I'm just going to try and hold my breath as much as I can, drive down the street with the windows all down, and hopefully all this stuff will go out. Well, they start doing that, and all of a sudden the mobile data terminal goes on the fritz. And then the radio goes on the fritz. And almost everything electrical in that cab all of a sudden started acting up and doing all sorts of weird things. And it was the dry chem got in. So Yeah, some paramedics got a little talking to, and they were in pretty deep trouble. Everybody was able to figure out who it was. And, it was a funny practical joke. It seemed like a good idea at the time, right? Well, CO2 is better for electronics to put out a fire in an electronics room and limit the damage that a fire could do in any kind of a computer room or electronics room. So the one thing it's not suitable for is reactive metals, materials containing oxygen, metal hydrides. So these systems are engineered to be specific to the equipment or the process or the things that it's protecting. They're self-contained, so we start, like we saw with wet chem and dry chem, all of these systems have similar properties to them. We have a cylinder or a tank. It goes through piping to where the equipment is or the room is. And then there, with CO2, one thing that's unique is some of the times we have these manual hose reels where they can take and use it like a water hose and go to where the problem is with the hose reel and spray it on the piece of equipment that's needed. That's just for manual uses. If not, there'll be fixed nozzles which shoot it down on the equipment and delivers the agent. So either a manual hose reel or a fixed nozzle. All equipment, though, has to be listed or approved with companies like UL or FM, Factory Mutual. There's a few types of systems and methods that exist, and they depend on the hazard and the amount of agent that's needed as to which system they're going to have. There's lots of different nozzles, and they're used, like we saw with wet chems in kitchens, there's different nozzles for different situations. So, if you have one that needs to be directed right onto something, that's a different nozzle than one that fills a whole room. So they have different flow rates, different discharge patterns. The discharge nozzles have to be able to withstand heat and the pressure that's going to be in the CO2 system. Now, you might remember we've talked about CO2 is sometimes used as the gas to expel a dry chem or a wet chem product. And the CO2 is going to help in that it chokes the oxygen, but it's actually being used to push it out. Well, you don't need that with CO2 because it's already pressurized. So as soon as it opens up, boom, it starts shooting out because it's under pressure and wants to come out. The pipe and the nozzles have to be able to handle that kind of pressure. They usually have blow-off caps or frangible discs that are going to pop off, and they're there to keep it from getting clogged by products in the area where the equipment is. Again, they all require listing and approval. Well, how is it activated? Usually it's an automatic detection system tied into the alarms. Or it might be a manual pull that when a person pulls it, then the alarm turns on and the fire alarm control panel sends a message to the CO2 system to turn on. These have to have warning signs that are posted about the dangers and give emergency instructions. So with all of the systems we're going to talk about today, there's a pre-alarm to the alarm. And the first alarm is, hey, my system's going to turn on. And it's warning them because sometimes they have an abort switch. So if there's an abort switch and the system is turning on for, it's not needed, it's not a fire, but it detected something incorrectly or a glitch in the system, there is a way to turn it off and keep it from happening. All of these things, the way that it's designed, engineered, and installed, inspected, tested, all of that is in NFPA 12. That's the standard for CO2 systems. So I mentioned that there's different kinds. There's low and high pressure. So the low pressure is usually stored at about 300 psi. The high pressure systems are up at 850 psi. So they're going to come out with enormous velocity. Both systems dispel the gas without any additional propellant, as we talked about, and the system is going to be chosen by the engineer who designs it based on the kind of hazard and the amount of CO2 needed and the standards in NFPA 12. So the low pressure systems may need refrigeration or heating equipment to maintain the CO2 at 0 degrees Fahrenheit. The low pressure systems may use one large pressure container like the picture on the upper left, okay? So that photograph shows a big, huge tank, and that tank is actually under high pressure, but it's going to go into a system that lowers the pressure so it comes out at a lower pressure. So low pressure systems can use one large pressure container, and high pressure systems usually use multiple small cylinders connected to a manifold like you see in the bottom right picture. So here's a low pressure tank outside a building where it protects a chemical storage facility, and you can see all of the piping. It goes from that tank into the piping, comes out at the appropriate pressure based on the manifolds and the way it distributes it, and goes to where it's needed. Whether it fills a room or sprays down on a piece of equipment depends on the situation. Now, the automatic delivery systems, they're going to usually protect a specific area, a piece of equipment, a particular process or a particular operation, and it's going to detect a problem in the equipment. So a heat detector, a smoke detector, some kind of a detector, and then it turns it on. Total flooding systems, now they are usually, they're going to fill a whole room. So all of these systems that we're going to talk about have one or both, one or the other or both. This one can do both. It can be specific to a local piece of equipment or fill a whole room depending on the situation. So if it's a computer room, it would be a total flooding system. And it'll fill the whole enclosure with gas. Now, this is a local application system photograph where you have nozzles that are being pointed straight down and into a piece of equipment to starve the fire of oxygen. Now, there's manual delivery systems that aren't automatic, and in these systems, there's like a hand hose line, or some of them are on carts. I'll show you a picture in a second, and some of them are on hose reels. So usually there's a standpipe throughout the whole building. Sometimes that standpipe doesn't have stuff in it, but a vehicle has to pull up, connect to it, charge it with CO2, and then it comes out one of these hose reels or one of these carts. So it's used just like an extinguisher, but a hose line, or like in standpipes when we talked about type 2 systems where the hose is already there, the nozzle is already there, you just pull it out, turn it on, and it comes out. So that's the same here. So let me show you a picture, a hand hose system. So this is one like in a manufacturing plant where this might be in a central location, and if they have an issue with one of the pieces of equipment, they run over, they wheel this up to the piece of equipment, it's full of CO2, they turn it on, they spray the CO2 on the piece of equipment. Here's a hose reel type, and this consists of a hose reel, a rack, hose and discharge, and again, it's connected to fixed piping to supply the carbon dioxide. So for these industrial facilities, most of the time everybody's got to be trained to use these, And the standpipe system might be tied into already tanks, but like I said, the CO2 oftentimes in these is supplied on a vehicle that pulls up to the building. So let's say a place like Lockheed or Boeing, where they have a whole bunch of different facilities where they have all this equipment. Well, they have the standpipe set up, they have the hose reels set up, everything's pre-set up, but they have a vehicle that goes to wherever there might be a fire, connects to the standpipe, and that way they don't have to have tanks at every single one. They just have it in a vehicle. And they connect, just like a standpipe, they connect to a fire department connection that shoots the CO2 into the system, fills the standpipe, and then it comes out the nozzles when they need it. Kind of different. Well, what about these systems? When we're building them, they've got to be inspected. So the plumbing has to be inspected. Of course, the engineer is going to turn in the plans to a fire prevention inspector. The fire prevention inspector will make sure that everything is done according to the California Fire Code and NFPA 12, the standard. And then once it gets installed, then another inspector has to come out and watch a demonstration. So it has to be proven that it works. So then they're going to have standards that they've got to stick to. So they're going to have visual operational discharges when they install it, but then also periodically throughout the life of the system. So when the system is operational, they got to do weekly, monthly inspections to make sure that everything's in good condition. They need to see if there's any kinds of hazards or issues. Sometimes the rubber hose starts to get corroded and starts cracking. So if there's any signs of damage to the system or any signs of leaks, all of these things, it needs to be visually and then sometimes operated to inspect it, and then they keep records of that. Now, with the pressure on the low pressure systems, they need to check that. We'll talk about with CO2 extinguishers, the way they know if the cylinder is full or not is they weigh it. It doesn't have a gauge. But the low pressure, high pressure, they might have a gauge showing what the PSI is, but it doesn't tell them whether it's full or not full. That usually is done by checking the liquid level in the big tanks and in the cylinders, or by weighing it. Okay, that's it on CO2. I told you it was going to be a short one, and we got another one coming up. You need to watch the video about Halon, halogenated agents, and inert agents. Okay, they're similar but a little different.